Okay, we've spent a lot of time working with derivatives, right? And we have lots of different rules for calculating derivatives of functions. We have the product rule, quotient rule, chain rule, power rule, a whole bunch of them. Let's move on to chapter 3. And we will be returning to derivatives in a little bit. I would like to be able to take derivatives of just a few more functions that have come up in my life, like the natural logarithm or the exponential function and stuff like that. But we need to talk about what those functions actually are. And in order to do that, along the way, we need to talk about what numbers actually are. Oh, so I have a little presentation I whipped up here in Desmos. I'm going to be looking at the real number line. I'm only looking at the x-axis, but I am going to be plotting all of these vertical lines just to help make it show up a little bit better on the computer screen. Right now, I'm pretty well zoomed out, and I'm curious about the number x equals 1/7. So let me change colors there a bit. Let's put this in blue so you can tell it from the y-axis. And all I can really tell here, judging off of my zoom level, is that x equals 1/7 is a number between 0 and 2. And personally, I think we can do a little bit better than that, but that's the level of detail that I'm given. And I want to see how close I need to get before I can tell this apart from some other number, right? So at this level of zoom, I can tell that 1/7 is a different number from 0. Because this vertical line here is x equals 0. This vertical line here is x equals 1/7. But is 1/7 a different number from 0.14? Is it? Is it really? It should be. It better be. 7 times 0.14 does not make 1. But at this level of zoom, I can't actually tell those two lines apart. Do you see that? So even though algebraically I know that these are different from one another, in my picture I can't tell them apart at all, at least not at this level of zoom. So let me pull in until I can tell the two apart. So now I've zoomed in a bit now and I can see more grid lines being labeled here. Let's clean that up a bit. So here I can tell that 1/7 is a number between 0 and 0.5. Can I actually tell it apart from 0.14? Well, I can maybe see that red line a little bit to the left there, but it's still really hard to make out. Let me zoom in some more, see if I can do better. Okay, 1/7 is definitely a different number from 0.2, and it's definitely a different number than 0, but I'm still having some difficulty seeing that this number is different from 0.14. Let me zoom in further. Oh, okay, I think I see it. I think it's right. Oh, there. Okay, here we go. Now, at this level of zoom, I can tell the two different lines apart. X equals 1/7 is a different number from x equals 0.14, or 14/100ths if you prefer. And I can tell that because on the number line, here they are at different coordinates, right? In my picture, they are different vertical lines. Now, when I was way far away, I could have treated 0.14 as though it was 1/7, right? Close enough. Close enough is relative. When I'm far away, close enough could mean that they have the same first two digits. As I zoom in further, that's not going to cut it anymore. So here I am zoomed in, and I can tell that, oh, there is exactly 0.14. So that is just the name of one of my grid lines now. And I can tell that 1/7 is slightly larger than 0.14. Well, what about x equals, let's say, 142 on 1,000, or x is 0.142. Okay, well, that gives me another line. I would prefer that line to be red, please. Thank you. Well, that line I can now tell is different from 1/7, but only at this zoom, right? I could continue to put in more digits here. Let's say x is 1428 on 10,000. That's what it means to be a decimal of 0.1428, and so on. I'm just getting all of these, by the way, by reading off the first couple of digits of 1/7. And now this line in green, it's completely overlapped my blue line. Can I visually tell these apart? It's pretty hard at this level of zoom. I can go in, right? I can keep zooming in, and eventually one point, my 0.14 just completely falls off the map. And here I can tell that, oh yes, 0.1428 is a different number than 1/7. So as I zoom in, I can get better approximations. But notice, if I'm far away, well, here I can't tell the difference between only having 4 correct decimal places and, infinite decimal expansion. At this level zoom, I can't tell the difference between having 2 correct decimal places or 3 correct decimal places. If I keep pulling out, well, here, they all look pretty much the same. If this whole block represents 0 to 1, I can't really tell the difference between any 4 of these numbers, any 2 of them, compared one to the other. So that is really fascinating, right? Just trying to draw a picture and understanding where these things are. But there is a relevant lesson here, that every single real number can be approximated by these rational numbers, right? I'll say that again. Every single real number, if you have just some fixed amount that you've decided to magnify on the real number line, there will be simple fractions that you can just use instead, and you won't be able to tell the difference visually between the number that you wanted and your approximations. Now, as I zoom in further, I can get better and better approximations, and one way I can do that is with the decimal expansion. But what this means for us, now that we have this tool of limits, yes, I'm going to be using limits again for this section, is that every single real number is the limit of rational numbers. So for 1/7, I say that, okay, 1/7 is pretty close to 0.1. It's even closer to 0.14. It's even closer than that to 0.142. It's even closer than that to 0.1428, and so on. No matter how much I need to zoom in, there will be rational numbers along the way that are be close enough.